Hello, in this lecture we will find the value of DE. In the drawing we have triangle ABC. We know that CA equals to 2 units. CA equals to 2 units and BC equals to 8 units, and we also know that DE is parallel to AB, and DE is a natural number, or the size of DE is a natural number as G, and D, and we know that point G is the centroid of triangle ABC. That is to say, G is a point where the three medians of triangle ABC are intersect with each other. Okay? So actually CF is the median of triangle ABC, that is to say, it bisects AB, or it divides AB to two equal parts, that is to say AF equals to BF. Okay, we want to find out the value of DE. So first of all, we have a rule that relates to centroid of triangle. That rule is true for any triangle. So in any triangle, if we have triangle ABC, that could be any triangle, and AD is the median of triangle ABC, that is to say AD bisects BC, or AD divides BC to two equal parts, that is to say BD equals to DC, and we have also point, this is point G, and point G is the centroid of triangle ABC, that is to say at point G the three medians of triangle ABC are intersect with each other. So according to rule that I will call it rule 1, according to rule 1, the centroid G divides the median AD in a relationship that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Or we can also say that AG is twice as large as GD. AG equals to 2 times GD. Okay? And we actually can implement this rule, the rule number 1, in our drawing, because we know that point G is the centroid of triangle ABC. Therefore, according to rule number 1, point G divides the median CF in a relationship that equals to 2 to 1. So if CG equals to 2 units, then GF will be equal to 1 unit. Or we can also write down that CG is twice as large as GF, or CG equals to 2 times GF. According to rule number 1, CG equals to 2 times GF. CG equals to 2 times GF. Actually, CF is the median of triangle ABC, that is to say, it bisects side AB, or it divides side AB to 2 equal parts. AF equals to FB, and according to rule number 1, CG equals to 2 times GF, and if we define CG as 2x, if CG equals to 2x, then we can substitute CG in this equality by 2x, and we will get that 2x equals to 2 times GF. Then we will divide this equality by 2, and we will get that GF equals to x. So we found out that if CG equals to 2x, then GF will be equal to x. So if CG equals to 2x, then GF will be equal to x. Okay? And we also have rule number 2. Rule number 2 states that in any triangle, rule number 2 is valid in any triangle, it is true in any triangle. If we have a triangle ABC, and we know that DE is parallel to BC. In triangle ABC, we know that DE is parallel to BC. Then, according to rule number 2, AD over DB equals to AE over EC. Okay, I will repeat on rule number 2 again. Rule number 2 states that if in triangle ABC, that could be any triangle, we know that DE is parallel to BC, then AD over DB will be equal to AE over AC. And again, we can implement rule number 2 in our drawing, because in our drawing we know it is given us in the question that DE is parallel to AB. DE is parallel to AB. DE is parallel to AB. And therefore, if we relate to triangle ACF, if we relate to the green triangle ACF, So in the green triangle, we know that DE is parallel to AB. Therefore, according to rule number 2, CD over DA will be equal to CG over GF. Again, if we relate to the green triangle ACF, we know that DE is parallel to AB. Therefore, according to rule number 2, CD over AD or CD over DA equals to CG over GF. Okay, that is according to rule number 2 in triangle ACF. In triangle ACF, we know that DE, the green triangle ACF, we know that DE is parallel to AB. Therefore, according to rule number 2, CD over DA equals to CG over GF. That is according to rule number 2. And we know that CG equals to 2x. And GF equals to x. So actually 2x over x is 2 because x over x is 1, so x will get cancelled. So 2x over x is 2, x over x is 1, and 2x over x is 2. So we got that CD over DA equals to 2. Here we will multiply this equality by DA, and we will get that CD equals to 2 times DA. CD equals to 2 times DA. So, and if we define CD as 2y, that is to say CD equals to 2y, then we will substitute CD by 2y, because CD equals to 2y, we will get that 2y equals to 2 times DA. We will divide this equality by 2, and we will get that DA equals to y. So we found out that if CD equals to y, then DA will be equal to y. So we can write here that if CD equals to 2y, then DA will be equal to y. Okay? So actually we have another rule. I will call it rule 3 or rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Rule number 3 states that corresponding angles between parallel lines are equal to each other. So I will read rule number 3 again. rule number 3 says that corresponding angles between parallel lines are equal to each other. And again, we can implement rule number 3 in our drawing, because we know that in our drawing that line segment DE is parallel to side AB of triangle ABC. DE is parallel to AB, it is given us in the question. DE is parallel to AB. Therefore, according to rule number 3 that states that corresponding angles between parallel lines are equal to each other, those two corresponding angles that are located between parallel lines will be equal to each other. That is to say, angle BAC, this angle will be equal to angle CDE. Okay, angle, according to rule number 3, angle BAC will be equal to angle CDE, and if one angle BAC will be defined as alpha, then angle CDE will be also equal to alpha because of the fact that those two angles are equal to each other. Okay, so angle BAC is equal to angle CDE, and both angles are equal to alpha. That is according to rule rule number 3. And for the same reason, those two angles will also equal to each other, because those two angles are corresponding angles. Angle ABC and angle DEC, those two angles are corresponding angles, and they are located between parallel lines. Line DE is parallel to line AB, so those two angles that are located between parallel lines will be equal to each other. That is to say, angle ABC will be equal to angle DEC. Angle ABC will be equal to angle DEC according to rule number 3. And if angle ABC equals to beta, then angle DEC will be also equal to beta because of the fact that those two angles are equal to each other. Okay? Again, angle ABC equals to angle DEC, and those two angles are equal to each other. They are both equal to beta according to rule number 3 because of the fact that those two angles are corresponding angles, and they are located between parallel lines. Line DE is parallel to line AB, and those two angles are located between those two parallel lines. Therefore, they are equal to each other according to rule number 3. So we found out that angle BAC equals to angle CDE equals to alpha according to rule number 3, and the angle ABC equals to angle DEC equals to beta. That is also according to rule number 3. And we also know that angle C, this angle C is a common angle. It belongs both to triangle ABC, and it also belongs to triangle CDE. So we can write down that angle C equals to angle C because it is a common angle. It belongs to both triangles, to triangle ABC and to triangle CDE. So angle C equals to angle C. It is a common angle. Okay, so we actually proved that the three angles of triangle ABC are equal to the three angles of triangle CDE. Therefore, triangle ABC will be similar to triangle CDE according to angle similarity rule. So I will write it down. Triangle ABC is similar, that is the sign of similar, to triangle CDE according to angle similarity rule. Okay, so what is angle similarity rule? Angle similarity rule states that if you have one triangle that three angles of it are equal to three angles of another triangle, then those two triangles will be similar to each other according to angle similarity rule. Okay, so actually from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC will be equal to DE over AB. I will repeat again, from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC will be equal to DE over AB. Okay? But what is the value of CD? CD equals to 2y. And what is the value of AC or CA? CA equals to CD plus AD, and CD plus AD is 2y plus y. 2y plus y, that is to say 3y. So we found out that actually 2y over 3y equals to DE over AB. 2y over 3y equals to DE over AB. Y over y is 1, so y will get cancelled, and we left only with 2 over 3, so we found out that DE over AB equals to 2 over 3. Okay, so here we will multiply this equality by AB, and we will get that 2/3 AB equals to DE. So we found out the value of DE. DE actually equals to 2/3 AB. We found out that DE equals to 2/3 AB. And we actually have rule number 4. Rule number 4 states that rule number 4 is true for any triangle. So if we have triangle ABC that could be any triangle, And we know that the size of side AB of triangle ABC is A units, and the size of side AC of triangle ABC is B units, and the size of side BC of triangle ABC is C units. Then the rule is actually states that the sum of the length of two sides of any triangle is always will be greater than the length of the third angle. That is to say, A plus B will be greater than C. The sum of the two sides of triangle, that could be any triangle, that is to say A plus B, will be greater than the length of the third side, or the length of two sides of a triangle, that is A plus B, will be always greater than the length of the third side. Okay, the length of two sides of the triangle, that is actually A plus B, will be always greater than the length of the third line of the third side. And rule number 4 also states that the difference of between the length of two sides, the difference between the lengths of two sides of the triangle will be always smaller than the length of the third side. That is to say, A minus B the absolute value of A minus B will be always smaller than the length of the third side. That is to say, will be always smaller than the length of side BC of the triangle, that is actually C. So the rule actually states that the length of two sides of the triangle will be always greater than the length of the third side, while the difference of two sides of a triangle, the difference between the lengths of two sides of a triangle will be always smaller than the length of the third side. Okay? So I will write down the rule I will explain the rule. I will write down the rule by words and not only by the inequality. Actually, the rule states that the lengths of two sides of a triangle of the sum of the length, the sum of the lengths of two sides of a triangle is greater than the length of the third side I read rule number 4 again. The sum of the length of two sides of a triangle is greater than the length of the third side, and the difference between the lengths of two sides of a triangle is smaller than the length of the third side. I will read the second part of the rule again. The second part of the rule is that the difference between the lengths of two sides of a triangle is smaller than the length of the third side. Okay? So, I will read the rule again from the beginning to the end. The sum of the length of two sides of a triangle is greater than the length of the third side, and the difference between the lengths of two sides of a triangle is smaller than the length of the third side. Okay, that is rule number 4. So we actually can implement rule number 4 in our triangle ABC. According to rule number 4, side AB of the triangle is smaller than side AC plus side CB, according to rule number 4, and the difference and the side AB is greater in its length from AC minus CB in its absolute value. Again, according to rule number 4, if we relate to triangle ABC, side AB of triangle ABC is smaller in its length from AC plus CB from one side, but it is greater than the absolute value of AC minus CB. Okay, that is according to rule number 4. But what is the value of AC? We know that AC, it is given us the question, equals to 2 units, and CB, BC or CB, it is the same, equals to 8 units. So 2 minus 8 in its absolute value is smaller than AB from one side, but from the other side, AC 2 plus CB 8, AB is smaller than 2 plus 8. So according to rule number 4, we have this inequality, and AC equals to 2, BC, CB equals to 8. So actually AB is smaller than 2 plus 8, and it is greater than the absolute value of 2 minus 8. Okay, we will get that AB actually is smaller than 2 plus 8 is 10, and it is greater than the absolute value of 2 minus 8 is minus 6. The absolute value of any number is its distance from 0. The distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. So AB is greater than 6 and it is smaller than 8. But we have already found out that DE equals to 2/3 AB. Okay? We found out that DE equals to 2/3 AB. Okay? So DE equals to 2/3 AB. We will multiply this inequality by 2/3, and we will get that 2/3 AB is smaller than 2/3 times 10, and it is greater than 2/3 times 6. Okay? So we know that 2/3 AB equals to DE according to this equality, so we can substitute 2/3 AB by DE in this inequality, and we will get that DE is greater than 2 times 6 is 12, 12 over 3 is 4. So DE is greater than 4, and it is smaller than 2 times 10 is 20, and 20 over 3 is 6.66. 6.66. Okay, so we found out that DE is greater than 4 and it is smaller than 6.66. But we also know, it is given us in the question, that DE is belongs to the natural numbers. Maybe I didn't write it, but DE, it is given us in the question that DE belongs to the natural numbers. So we know that DE is a natural number, according to what is given us in the question. Okay? So which natural numbers we have that are greater than 4 and smaller than 6.66? We have only two natural numbers that are greater than 4 and smaller than 6.66. That is to say, the natural numbers are 5 and 6. So DE will be equal to either 5 or 6 units. So the answer to the question is that DE equals either to 5 units or to 6 units. Okay, so here the size of DE is actually either 5 units or 6 units. Okay, that is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the value of DE. We know that DE is a natural number. I didn't write it in the beginning of the question, but now I will say that we know that DE is a natural number, And we also know that CA equals to 2 units, we know that CB equals to 8 units. We also know that DE, that is natural number, is parallel to AB. And we also know that G is the centroid of triangle ABC. So what is the centroid? Centroid is a point where the three medians of a triangle are intersect with each other. Okay, so actually CF is the median of triangle ABC, that is to say, it bisects AB, or it divides AB to two equal parts, that is to say AF equals to FB. Okay, and we actually have rule number 1 that relates to the centroid of a triangle. If we have triangle ABC that could be any triangle, and we know that AD is the median of triangle ABC, that is to say it bisects BC, or it divides BC to two equal parts, that is to say BD equals to DC. And we know also that G is the centroid of triangle ABC, that is to say it is a point where the three medians of triangle ABC are intersect with each other. Then, according to rule number 1, the centroid G divides the median AD in a relationship that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. If AG equals to 2 units, then GD will be equal to 1 unit. Or in other words, AG is twice as large as GD, or in terms of equation, AG equals to 2 times GD. Okay, that is rule number 1, and we can implement rule number 1 in our drawing, because we know that G is the centroid of triangle ABC, that is to say it is a point where the three medians of triangle ABC are intersect with each other. Therefore, according to rule number 1, the centroid G divides the median CF in a relationship that equals to 2 to 1. That is to say, if CG equals to 2, then GF will be equal to 1. Or we know that CG is twice as large as GF. That is to say, CG equals to 2 times GF according to rule number 1. That is true according to rule 1. Okay? So, if we define CG as 2x, if CG equals to 2x, then we can substitute CG in this equality by 2x, and we will get that 2x equals to 2 times GF. We will divide this equality by 2, and we will get that GF equals to x. So we found out that if CG equals to 2x, then GF will be equal to x. So we can write here that if CG equals to 2x, then GF will be equal to x. Okay, and we also have rule number 2, that it is true in any triangle. Triangle ABC could be any triangle, and if we know that the line segment DE is parallel to BC, then AD over DB will be equal to AE over EC, and this rule is true for any triangle. So if DE is parallel to BC in triangle ABC, AD over DB will be equal to AE over EC. Okay, so again we can implement this rule in our drawing, because we know, according to what is given us in the question, that DE is parallel to AB. We know that DE is parallel to AB. So if we relate to the green triangle, to triangle ACF, we know that DE is parallel to AB. So we can implement rule number 2 in triangle, the green triangle, triangle CAF. And according to rule number 2, CD over AD will be equal to CG over GF. Again, we know that in the green triangle, we have DE that is parallel to AB. Therefore, according to rule number 2, CD over AD will be equal to CG over GF. In the green triangle, triangle ACF, we know that DE is equal to AB. Therefore, according to rule number 2, CD over DA will be equal to CG over GF. But what is the value of CG? CG equals to 2x and GF equals to x. So CD equals to 2x and GF equals to x. So 2x over x is 2, because x will get cancelled. So we got that CD over DA equals to 2. And if we multiply this equality by DA, we will get that CD equals to 2 times DA. CD equals to 2 times DA. So if we define CD as 2y, that is to say, if CD equals to 2y, so we can substitute CD by 2y, because CD equals to 2y. We'll get that 2y equals to 2 times AD. This equality, from this equality, we will get that 2y equals to 2 times AD, or 2 times DA. We'll divide this equality by 2, and we will get that DA equals to y. So we found out that if CD equals to 2y, DA will be equal to y. So here, if CD equals to 2y, then DA will be equal to y. Okay? Then we have also rule number 3 that states that corresponding angles between parallel lines are equal to each other. Okay? And we have in our drawing, we know that DE is parallel to AB. So according to rule number 3, because of the fact that we have two parallel lines that are DE and AB, so the corresponding angles that are located between the two parallel lines will be equal to each other. Those two corresponding angles that are located between parallel lines will be equal to each other. That is to say, angle BAC will be equal to angle CDE, and if one angle is equal to alpha, then the other angle will be also equal to alpha, because they are equal to each other. So that is according to rule number 3. Those two angles are two corresponding angles that are located between parallel lines. That is to say, DE is parallel to AB. Therefore, those two corresponding angles will be equal to each other, and both of them equals to alpha. And we have the same rule number 3 in the other side of the triangle ABC. We have line DE that is parallel to line AB, and those two angles are located between those two parallel lines. Therefore, they will be equal to each other according to rule number 3. And if one angle is beta, then the other angle will be equal also to beta, because they are equal to each other. Okay, so according to rule number 3, angle ABC will be equal to angle DEC, and both of them will be equal to beta, according to the rule that those two corresponding angles that are located between parallel lines are equal to each other. Okay, so we have here those two angles are equal to each other, and those two angles are also equal to each other, and we have the third angle. This angle is a common angle. It belongs both to triangle CDE, and angle C also belongs to triangle ABC. So angle C equals to angle C. So we actually proved that all the three angles of triangle ABC are equal to the three angles of triangle CDE. Therefore, triangle ABC is similar to triangle CDE according to angle similarity rule. What is angle similarity rule? If you prove that three angles of one triangle are equal to three angles of the other triangle, then you actually prove that those two triangles are similar to each other according to angle similarity rule. So we prove that triangle ABC is similar to triangle CDE according to angle similarity rule. And from the fact that those two triangles, triangle ABC and triangle CD, are similar to each other, we can conclude that CD over AC equals to DE over AB. From the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Okay, but what is the value of CD? CD equals to 2y. What is the value of CA? CA equals to CD plus DA. That is to say, CA equals to 2y plus y. That is to say, to 3y. So CD equals to 2y and AC equals to 3y. So we got that 2y over 3y equals to DE over AB. We multiply this equality by AB, or DE over AB equals to 2 over 3, because here y will get cancelled. We got that DE over AB equals to 2 over 3. Here we multiply this equality by AB, and we got that 2/3 AB equals to DE. So DE equals to 2/3 AB. And we also have rule number 4, that is true for any triangle. This triangle ABC could be any triangle. According to rule number 4, the sum of the lengths of two sides of a triangle is greater than the length of the third side. So actually this rule states that the sum of two sides of a triangle, the sum of the length of two sides of the triangle will be always greater than the third side. That is to say, A plus B will be always greater than C. Okay, A plus B is greater than C from one side, and from the other side, the difference between the length of two sides of a triangle is smaller than the length of the third side. That is to say, A minus B will be always smaller than C. Okay, from one side, A plus B will be always greater than C, while A minus B will be always smaller than C, or will be always smaller than the absolute value of C. C will be greater than the absolute value of A minus B. From one side, and from the other side, C will be smaller than A plus B. Okay? Again, the sum of the lengths of two sides of a triangle is greater than the length of the third side. That is to say, A plus B is greater than C. And the difference between the lengths of two sides of a triangle is smaller than the length of the third side. That is to say, A minus B is smaller than C, or the absolute value of A minus B will be always smaller than C. Okay, that is rule number 4, and we actually can implement rule number 4 in our triangle ABC. If we relate to side AB of triangle ABC, we know that AB will be smaller than AC plus CB. According to rule number 4, AB will be smaller than AC plus BC from one side, but AB will be greater than AC minus CB from the other side. AC will be greater than the absolute value of AC minus CB from the other side. That is according to rule number 4. This inequality is the implementation of rule number 4 in our triangle ABC. Okay? But we know that AC equals to 2 units and CB equals to 8 units. So AC minus CB is actually 2 minus 8, that is minus 6. Okay? And the absolute value of any number is the distance of the number from 0. The distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. 2 plus 8 is 10. So we found out that AB is greater than 6 and it is smaller than 10. But we have already found out that DE equals to 2/3 AB. Okay, DE equals to 2/3 AB. Okay, DE equals to 2/3 AB. So we multiplied this inequality by 2/3. So AB times 2/3 is 2/3 AB. Here 6 is multiplied by 2/3 and here 10 is multiplied by 2/3. And we know that 2/3 AB equals to DE, so we can substitute 2/3 AB by DE according to this equality. So after we substituted 2/3 AB by DE, actually 2 times 6 is 12 and 12 over 4 over 3 is 4 and 2 times 10 is 20, is 20 over 3 is 6.66. And here 2/3 AB is DE according to this equality. So in total we got that DE is actually greater than 4 and it is smaller than 6.66. But we also know it is given us in the question that DE is a natural number. It belongs to the natural number. So the size of DE is a number that belongs to the natural numbers. So which number or numbers we have that are greater than, which natural numbers we have that are greater than 4 and that are smaller than 6.66? We have only two numbers that are 5 and 6. 5 and 6 are greater than 4 and also smaller than 6.66. So the final answer to the question is that DE equals either to 5 units or to 6 units in its size. Again, the size of DE is either 5 units or 6 units. And that is the final answer to the question. Okay? Thank you very much.